Okay, welcome back students. So we're doing question 3 from the 2022 paper, and we're told there's a road here that is superimposed on our coordinate plane. So they tell us that the point Q has coordinates 6, 2, which is indeed true because we can see that it's in the correct place here. Write down the coordinates of the point P. So the coordinates of P are -1 and then 3. -1 for the x value and 3 for the y value. The equation of this line PQ, we're told, we could have calculated it, but we're told it's x plus 7y equals 20. Using this or otherwise, find the coordinate of the point where PQ crosses the y-axis. Okay, let's think our way through this now again. On the y-axis, we know something very specific about the x value. We know it's 0. So when it says y-axis, we have x equals 0 available as a substitution. Okay, so let's go ahead and do the substitution and show our work. So instead of x, we're going to write 0, we don't need a bracket for that, plus 7y equals to 20. Okay, so now we'll try to isolate y by dividing out the 7. Y equals 20 over 7. Okay, and that's our answer here. Really no reason to go to decimal, it'll be a bit of a mess with a repeating block of 6 digits over and over again. So we're leaving it like this. We know our x value is 0 and our y value is 20 divided by 7. Okay. Let's see how we're doing. Great, we got that out. Okay. Moving on. Let's give ourselves those 10 marks. A new road is being built through the point 6, 2. So there's going to be a new road through Q here. Okay. On the coordinate diagram, it will be a straight line segment which is perpendicular to PQ. Okay, let's see, can we construct that in preparation for any algebra we might need to do. Okay, so when it comes to create, well, it's going to be difficult to create because what I have here is I'm going to put in what we call the supporting triangle here, which has a side of 1 and a length here of 7. 1 and 7. So what we want to do here is go out 1 and up 7, and it's off the charts. So what I'll do instead for my construction is I'll use a right angle set square. To get the idea and to show how we understand what we're talking about here so far. So we're creating this road. Okay. Okay, so what we're going to bring into the fact is we have an equation for a line when what we call the point slope. It doesn't say it here, it just says the equation line. But this is the point slope form, and that's one thing we can use here. And another thing we need to know is how to get a perpendicular line. Okay. So I'm going to do it in the more traditional way, and then towards the end I'm just going to show you a quicker way to do it. So we have x plus 7y equals 20, and we need to know the slope of this line. So we'll remind, did it give us the name of that line? It didn't, but we'll just start off with our x plus 7y equals 20, and we want to get the slope. So one way is to isolate y. We want to get it into y equals mx plus c format. Okay, so what we'll do is we'll bring the x term across, we'll transpose the x term, and I would divide down by 7. We're getting y equals minus 1 over 7 x plus 20 over 7. So there's your slope there. A quicker way of doing that would have been turn the plus into a minus and put the number in front of x on top and a number in front of y on the bottom. Either way we get this. This might be more you could end up forgetting this, so be careful. So we'll go with this. Now the perpendicular slope is the opposite sign, so it's positive, and it's the reciprocated version, so it's plus 7 over 1, okay, or m equals 7. So now we're going to use the formula at this point that I showed you here. So we write down the formula. Y minus y1 equals m times x minus x1. And we have y minus the y value there is 2 equals 7 times x minus the x value there is 6. Okay, now we do need to tidy that up. I'm just going to do my work down here because it really actually doesn't matter what box you go into. So you do your work into. They're all corrected. Equals 7x, and I want to say that is explicitly stated to us as examiners when we're correcting. If we're to correct anything on the page regardless of where it appears. Okay, so now we'll check again where the format we want is what's called general format with all terms to one side and no fractions. Okay, so the number bits will have to clean themselves up. They want the x value first, so if we don't start negating, that 7x comes back to become minus 7x. That y stays as plus 1y or plus y, and the negative 42 comes back, transposes back to become plus 42. When you take away 2 from that, you get 40. Okay, so that's the answer for there, and you can just do your work that way, it's fine. Okay, they told us a, b, and c are real numbers. Indeed, they actually really want them to be integers. It's better. Okay, let's see how we're doing. So in part C, the answer is 7x minus y minus 40 equals 0. Okay, now we have the reciprocated version of that. It's 100% correct. They only want us to use real numbers, and that's the way it panned out for us when we used the formula. So we're not worried about that and feel that we haven't finished. We have finished, and we get 4 marks for that. Okay, on we go. The distance PQ on the diagram is 7.1. Coming back to this, I'm just thinking this through. If you want to lead with a positive, then you can say I'm not going to allow a negative here, and you can change it. You can negate or change the sign of every single term along the way. Okay, and that's up to you. That's something we might look at as we do more and more questions. If we see that they always do make it positive, then for our own satisfaction, in order to be matching the marking scheme, we might lead. I'm not saying lead with a positive coefficient. Okay, it's not necessarily, it's purely a habit. The distance on the distance from P to Q on the diagram is 7.1. Well, we don't need to take their word for it. We know it's using 7 and 1 in Pythagoras. Yeah, so it does indeed round to 7.1. Correct to 1 decimal place. True. 5 millimeters, and then we're told that 5 millimeters on the diagram represents 100 meters. So we're going to be actually using the diagram to scale here. Maybe use this to work out the actual distance from P to Q and give your answer in kilometers. So we don't need to use Pythagoras, it's already done for us. We want to convert, so let's set up a proportion. So the scale is 5. If we have millimeters being compared, so the microscopic, the drawing compared with the real world, we put millimeters here and meters here. 5 millimeters is worth 100 meters. Okay, use this to work out the actual distance. So we need to take our 7.1 and turn it into millimeters, which is 71 millimeters, and we need to know what goes here. What is the distance, the actual distance from P to Q? Now they'll probably go like this, PQ with bars at the side of it, rather than introduce a variable. Okay, and we can set up our proportions in any way we want. Let's put it on the top corner. PQ divided by 100 is equal to 71 divided by 5. So we're divided that way and divided that way. Okay, and so you get, and we're getting our answer, by the way, in meters. So you get 7,100 when I multiply them together and divide by 5. Okay, I'll put in the calculator. And we get 1420 meters, 1.42 kilometers, and so on. We make absolutely sure, give your answer in kilometers, equals 1.42 kilometers. Okay, worth 5 marks. Let's see how we're doing. Which is equal to 1.42 kilometers. Great. Okay, as always, see you in the next one.